Technologies, the president and owner. We've been in the surge tank business since 1978. I have personally, and we're here to kind of give you the basic overview of this surge system and basically kind of give you a nice idea of how to operate these surge tanks. So you got a good idea of what they're here for and what we can actually do as far as maintenance, troubleshooting, going over the operating parameters that we've currently got set up for this project. Has any of you guys been trained on surge systems before? You have? A little bit? Well, let me go over the basics. You know, basically, we've got 5 pumps over there that are pumping through a discharge pipeline, and this surge tank's connected up to that discharge pipeline. And really what we have, we've got a tank that's been sized specifically for this project, and what it does, it actually will dampen the effects of the starting and stopping of the pumps. And then also, if we had an emergency shutdown with full maximum flow, it's there to protect the pipeline from any transient surges. And, you know, I liken these surge tanks to, you know, the easiest way to relate to it is, you know, when you go into an older house sometimes and you turn on a faucet and it's running, then you shut it off, and then you hear those pipes, you know, rattling inside the old houses, you know. That's really what we call a surge. I mean, it's the same type of effect, that water hammer effect. And what these surge tanks do is dampen that effect. Basically what we have, the tank is about 50% air and 50% water. That air cushion is really what we have as a giant shock absorber, and that air, because it can compress and expand, that's what dampens the effect of the surge system, the surge effects that we have from starting and stopping of the pumps. Now, when we went through testing with pumps running and pumps shut down, this particular surge system is very stable. We've seen very little effects from surge conditions and emergency stop condition, which would be the absolute worst condition that this surge tank could affect. There you go, right there. You know, we found that we saw maybe in 2 or 3 pumps running a maximum pressure, what we call a pressure wave, of about 12 inches down and about 4 or 5 inches up. In a surge tank, what happens, like when that pump just shut off, what happens is that we've got effluent flow. We've got all this water leaving the pump station. Well, that void, because of the velocity of the pipeline, this surge tank fills that void of the pumps, and eventually when that flow stops, typically it's going to cause a pressure wave to come back at the pump station. And all we do is just dampen those effects of the surge tank. The surge tank has no moving parts inside. What we do have on this inlet outlet, and there's only one inlet outlet, that's the difference between a surge tank and a hydrodynamic tank. A hydrodynamic tank basically will maintain pressure in a distribution line, where a surge tank, it dampens those surge effects, and it acts very similar, but in a surge tank we only have one inlet outlet, and that inlet outlet, on the inside we have a 90-degree elbow and a vortex breaker typically in there to so you have, one of the worst things that could ever happen is that we would allow air to get inside the pipeline, because what happens, you get air inside of a pipeline, all of a sudden it compresses, and it causes, you know, bad effects on the pipeline at maybe a further point away from the pump station. So we do that by our liquid level controls. But basically, we have a probe well. That basically, in this case, it has a single probe, and we'll get to that here in a little bit. We'll basically go over what we have. We have a sight glass, so we have visual indication of what's going on inside the surge tank. And then we have a pressure gauge, and then at the very top of the surge tank we have a pressure relief valve. Now these surge tanks, in all cases, the working pressure of the surge tank is always much greater than what any anticipated surge that we would see, plus we have a safety factor because it's an ASME code tank of 3 to 1. That PRV up at the top is there to protect from overpressurization of the compressed air system ever being allowed to overpressurize the tank. Now typically that can only occur is if we had a discharge pipe, if the tank was isolated from the discharge pipeline, shut off, and somebody came over here and just turned the air on, and all of a sudden that's the only way that you can actually create excess pressure inside the tank. You know, that's one of the things that you need to be aware of, is that because liquid is not a compressible, you know, liquid cannot be compressed. Air is the only thing that can be compressed. So that compression effect is the only thing that would increase pressure. That is not a normal operating condition. But what we'll do now is I'll kind of go over what we have on the. What we have is, we refer to them, I mean, they're really a capacitance probe, but we call them RF probes. It's made by Endress+Hauser. It's a single half-inch diameter rod that goes the full length of that probe well, and it senses the water level by the different conductivity between the air and the water, and it turns that signal into a 4 to 20 milliamp output. There's, you know, in a lot of cases we have conductive probes where individual probes have individual operations. Well, in this case, we're taking that 4 to 20 milliamp signal and sending it to our control panel, and it's being processed through a PLC. The other feature that we have, and we didn't have the level settings at the time, but we do now. I will get you a new scale. This is a feature that we add to all of our surge systems, and we actually engrave the various liquid levels, actuation points for the surge system. Basically, we have what we call steady state. Steady state is the actual operating level that we're trying to maintain. And then we have a working range between add air and vent air. So that is the operating range of the surge tank, and it's fairly narrow. In this case, I believe that we've got a working span of about 6 inches. So if we've got our steady state level that we're trying to maintain at 50%, if the level rises up 3 inches, we're going to have, after a time delay, we're going to have a call for air, and that air is going to actually, it'll actuate a solenoid valve in which we're going to add air, and it's going to push the liquid level back down. And you know what happens is this compressor mainly becomes like a pump. It's not adding pressure. What it's really doing to the system is just pushing that liquid level back down. Now, the other effect that we have is if the liquid level is too low, well, we're going to, after a time delay, we're going to vent air, and we're going to allow the system pressure to come back up to its liquid level, and then we're going to shut it off. Now, what happens basically in a discharge surge system, we don't really vent much. It's more of a function of adding air than it is for venting air. And the reason for that is that because we're in a pressurized air over water system, then what happens is we get air absorption. This air is slowly actually absorbing itself into the water. So over the starting and stopping of the pumps and over time, our liquid level is slowly going to rise over time, and that's going to cause us to have to add air, push our liquid level back down. This system typically operates between 115 and 138 psi, 140, a little bit higher than that. 146 maximum. So we're really, that's kind of a standard range for surge tanks. You really don't have a huge, some of our systems we operate at 500 psi because we're pumping up a hill, and all that static head pressure that we have. In this case, we really don't. It's well within, a standard potable water system in the 120 to 150 psi range. That's the basic features of the actual surge tank itself. We'll move on to the air volume control piping here in a second, but I don't know if there's any questions. Yes, sir.
You have your add air and your vent air limits. How high and above the add air is your high level alarm set at? Is that hard coded or is that user adjustable?
No, everything in this system is user adjustable. So, this system that we've given you here is every range is adjustable. We've set them at what we feel would be adequate. Typically, I think we'll go over the level settings here coming up on the screens. I will, show you guys exactly how to increase those levels if you feel, because a lot of times as you get a real good feel of this system as it's currently configured, you may want to change the operating range a little bit. But we do have time delays built in, and those are adjustable. So what we don't want to do is have any adding or venting air in any surge condition. This thing is designed that it's to rest online, and we just let it do what it's supposed to do during a surge condition. We don't want to add air, we don't want to vent air, and we don't want nuisance alarms. So I've set this system up currently as a 5-minute time delay for adding air and venting air, and I've given you a 10-minute delay for any alarms. Now, what we typically do, and the reason why I've got about 10 minutes in there, some are longer, is because we didn't see much of a surge condition during our startup phase. And typically what I do on alarms is I take a look and we go through emergency shutdown, and then we look and see how long does it take for this system to come back and be at its steady state condition again with very little pressure waves. Because after pumps are shut down, you're going to see a little rise and a little flow. You're going to see these pressure waves occurring inside the pipeline, and then when they steady out, I look at that and I say, well, if it takes 5 minutes to do that or 8 minutes to do that, then I'm typically going to double that for the alarms, because there's no reason to have nuisance alarms unless we have a real condition, either high or low. Does that kind of satisfy your question? One of the things that I'd like to mention is that if you find that this RF probe, and the nice thing is we're going to set their liquid levels, you know, with the gauge, and they'll be marked. And one of the things that you can do is that those are known liquid levels. So if our steady state's at 50%, that tank is 96-inch diameter. You know, we should be right around 48 inches, and we should be reading the same over here in our OIT. If you find that you're seeing a fairly large difference between the actual and what it's actually reading here, you can calibrate that RF probe. And it's a very simple, the instructions are in your O&M manual, and I can't stress enough that operators should have access to their O&M manuals, because that's where the knowledge is. That's where all your product literature is. That's where you're going to find out how to calibrate that probe. Now, it's very simple, and the nice thing is I always put some systems, and I fight engineers a lot over this, is that they want to stick that RF probe right inside the tank. Well, there's no real way to be able to test that probe if you don't have an external stilling well. The nice thing is you can test this system by isolating the two inlet outlets of the probe well. And maybe we should move over and kind of reposition so I can kind of go over this. This is important. This stilling well gives you the ability to be able to test the system without actually interrupting the process and keeping the tank online. One of the things that you can do, we have these isolation valves. You can shut the top one off, the bottom one off, and then you can drain the probe well completely out of air and water. That allows you to be able to leave that top valve closed, open this bottom valve, and you can fill the probe well to whatever desired level that you want. Now, you can take it all the way up to high level. You can test your high level alarms. You can drain it. You can get to your low level alarms. You can get to your add air, your vent air. That's a good way to be able to verify that your OIT is reading the same as, you know, within reason. I mean, you know, one of the things that we do have in this system is, you notice that the bottom of the probe well is higher than the bottom of the tank. What we've done, we've allowed in a what we call a probe calibration, that we can actually program into the OIT this offset. So this offset between the bottom of the probe and the bottom of the tank, we input that into the OIT screen, so we're getting real-time readings of what the liquid levels are inside the tank. And as far as I've seen so far, and since I've been here, it looks like we're still, you know, well within, you know, I mean, if you're within a quarter or a half an inch, I mean, you know, that's pretty doggone close. This is not an exact science. I mean, the difference, that 6-inch, you know, range that we have, I mean, it will protect the pipeline, especially in this case. Even if we had a wider span, you're still well protected with this system. The calibration of the probe is very simple. There is, at the top, there's a cap up there. It has a, it's got a couple of buttons, and you press both. What you do first of all is you empty out the probe well completely. Push both the buttons until the lights start flashing, and that will calibrate the empty. Then the next thing you do, you fill it all the way up to the top. And the only way you can accomplish that is to make sure that when it's empty, that you got all the pressure out. I mean, it should have no air pressure, no water, nothing. That'll allow you to be able to open this bottom valve and send the water pressure all the way up to the top. and you can push the button again, that gets your high. That's it. It's that simple. Those are also outlined in the Endressenhauser section of our O&M. There's a section in there on calibration. It goes through those steps, so if you forget it at a later date, go to the O&M manuals. It's there. Excuse me. That would be only if you had a condition where the OIT isn't reading what the sight glass is reading. But typically once we set them up, we find that there's zero problems. I mean, we've had this is a very reliable system from this aspect. Any questions?
Find any scaling issues on the RF probe?
No, you know, and I know you've got recycled water here. I mean, this probe has a Teflon coating on the outside of the probe. We haven't had it even in because you got fairly clean water here. There's not a bunch of high solids or things of that nature in your particular system. It's not a bad idea that maybe once a year to maybe clean the probe off. But typically, I wouldn't even worry about it unless you've gone through calibration and you've got an issue and it's still not reading quite right. You're getting some strange readings. Then maybe you do have a little scaling issues. At that time, the first thing I do is make sure that the probe's clean, and then go from there and recalibrate. Typically, you know, it's not a bad idea, especially in a reclaimed water system, to go ahead and, you know, because it is a stilling well, you don't get much flow in and out. You will see, because of, you know, it is highly, I'm sure you're pretty chlorinated here, so you shouldn't see much buildup in the sight glass. There is a drain valve here that you can open up that will actually, you know, clean the sight glass out a little bit. The other thing is you can do on the probe well is just open up the valve, kind of flush it out every so often. I'd say, you know, once a month, once every 2 months, it wouldn't be a bad idea. The system doesn't require maintenance, but little things like that would certainly help. Any questions? All right. I think we've talked enough about this portion of it. We'll move over to the liquid level controls section here. This is the heart of the system here as far as how we control liquid levels. You know, they have a little added feature in here for which is a good thing. We've got a high pressure pressure switch in case that there was a high pressure condition within the surge tank. This is a actuated pressure switch that will send alarm directly back to SCADA. Also, this is a low pressure alarm, and in any one of those two cases would certainly trigger a reason for an operator to come out and see why there could be in those two conditions. It could be as simple as somebody had the discharge valve off, left a bypass, add air. We created a high pressure condition due to you know, maybe your operator just forgot. I mean, typically we shouldn't see any high pressure applications because these pressure switches are set higher than any anticipated surge condition that we should see. It would definitely be an abnormal condition if you got one of your high pressure alarms. Now, a low pressure alarm, on the other hand, could be a simple reason that you've taken the system out of service, you've drained the air pressure, you know, for maintenance or something of that nature. And likewise with a low pressure condition, you shouldn't see any of those two conditions at all. We have 2 solenoid valves. These are ASCO solenoid valves. They require very little maintenance, if any. The only condition that I've ever seen in a new system is that they're actuated by a small needle valve on the inside. There's a small little actuator point inside that valve. If there's a little pebble that gets into the air line, if there's a little piece of Teflon tape that was able to get into the air line, and it's possible that that could get stuck. And the only time we've really seen a failure of these valves is probably because of one of those two conditions. You don't have to take the valve out of service to actually do your maintenance on it. If you have one of those conditions, the only thing that you really have to be aware of is that we've got a pressurized air system. So it needs to be isolated and it needs to be vented, and just to be sure, safety, to make sure that there's no air in this air volume control piping. You can take these 4 bolts off. The coil comes off. It's got a little clip. You can take the coil off. You can get to the body of the valve. You can go in there and look and see if you've got some kind of obstruction in there that's causing a problem. But typically, other than that, you really shouldn't have. I've seen a condition where up in Vegas where it's really hot, we do a lot up there, that the guys shut the pump station down. They forgot to shut down the surge tank. We were in a add air condition, and the solenoid just stayed hot. The compressor wasn't running, and you know, it just stays actuated for days and days and days at 120 degrees, and you know, I've seen the coils burn up. But they're easily replaced by ASCO. There's a lot of ASCO dealers around. It's readily available. So I mean, typically you could get it within 1 day and replace it the same day. We do, as you can see, we've got, this is your vent solenoid valve. You can tell by it's got a little muffler on it on the output side. I like these little mufflers, and I'm going to actually actuate one of them. It's really not that noisy. I mean, for a compressed air system. If it was open, just the atmosphere, we'd blow our ears out. You know, it's very noisy. But this, I like these mufflers. They're pretty good. This is your add air solenoid valve. Now, in every case, if this system ever went down, the control panel for any reason, you always have the opportunity to be able to manually add air or manually vent air to change the liquid level inside the tank. So you always have that option to manually add air. This is your bypass line. This is your vent line, your manual vent. If you manually vent it, you're going to raise the liquid level. If you manually open it up, you're going to add air. You're going to push the liquid level back down. So that's part of your features here. You got an isolation valve here, and then you can vent. Once you isolate both the inlet and the outlet, you can vent the air, and that would completely depressurize your air volume control piping. So you have the ability to isolate it and work on it. If you had a leak, you needed to, you know, I mean, stainless piping is notorious for leaks. Typically, once you get them sealed, you're pretty good. But in an outdoor application where you got heating and cooling, summer to winter, you know, this expansion and contraction of the material, sometimes you will get a leak. You may have to go ahead and do it. Any questions on air volume control piping? No. All right, we'll go on to the most important thing. This control panel has, and within the O&M manual, we've given you a pamphlet inside the, matter of fact, bear with me just a second, let me see if I can get that. O&M manual, near the back, we have this Surge System Monitoring HMI section. And this gives you a nice little overview of the screens, the screenshots, how to adjust the various liquid levels within the OIT. So I would highly recommend, if you're going to be an operator that's going to be part of this system, this is probably one of your most important documents to take a look at. It gives you all the different screenshots. It shows you where the inputs are that you can actually change. We're going to go over that too, but I mean, as soon as you leave here and a few hours later, you're probably not going to remember it all. Certainly you've got a video, but this pamphlet right here is a nice one to be able to take a look at and kind of refresh yourself on the screens. The first screen that we have is called the Surge Tank Overview. It actually it shows the solenoid valves and the actual liquid level inside the tank. So down here at the bottom, it's reading 43 inches currently. It's showing that the add air solenoid valve is off and the vent solenoid valve is off. So anytime that there's an actuation or we're adding air, you will be able to see that it goes from, it'll go to green, and then it will also say on. So you can actually know whether or not we're actually sending power out to the solenoid valves. The other trick on the solenoid valves to know, sometimes you can't really tell whether or not they're on or off. I always use a little screwdriver because we're creating a magnetic field on the coil. You can actually put a screwdriver right on the top of the solenoid valve and you'll feel that little vibration. If you feel that little vibration, then you know that that coil is activated. So that's just a nice little thing to know that you're getting power to the solenoid valve. Obviously on the vent valve, if it's venting air, it's actuated. One of the, in this main screen, this is a touch screen, at the very top we have that calibration section that I was telling you about. That's for the offset that we put in, because the tank probe is up above the bottom of the tank. So if we didn't have that, it's only going to read what the probe's seeing. Well, with this offset, that gets us to the real-time reading, and that is adjustable. If you find that you're on your set points that you're a 1/4 inch off a little bit on that 48, well, you can actually go in and put that 1/4 inch into the offset, so to make sure that they're reading exactly what they're supposed to be. Right now, it appears that we're still well within any type of calibration levels. And you can exit out of that. The other part of it is our level set point screen. So there's actually 3 screens down here at the bottom that really mean something to you guys. And that's the level set points. And this is our adding air and venting air screen. This is where you set your steady state levels, your adding air, and your venting air levels. Right now, we have the stop add air and stop vent, which is our steady state at 48 inches. Up above that, we've got 3 inches for adding air. So it's at 51 inches. The vent air I've given us a little larger range on the vent air because that is not a normal condition for a surge tank at 6 inches below. So it's set at 42 inches currently. Now you can tighten that up if you wanted to, but I'm thinking that for this particular application, our operating range of 9 inches is very sufficient for where we're at. Now also, on this side of the screen, you have your time delays. You know, remember we said we do not want to add air or vent air. Currently that's set at 5 minutes. That is also adjustable. It's as easy as going in here and touching on the 5 minutes, putting 5 in there, you have a little calculator that pops up, enter the values, push enter, and boom, there's your level set points. You can do that on your level set points and your time delays. So that's one of the things I like about this, is that the adjustability is really, really good. Now, the other screen that you had talked about was the alarm set points. That's your other screen. That sets your high level and low level alarms. Very similar to your add air and vent air screen, same way. Currently we've got it set at 54 inches and 39 inches. So basically 6 inches above our, let's see, we're 48, 51, 3 inches above our add air. If we fail to add air and that liquid level continues to rise, then you're going to get a high level or a low level alarm, and that's a direct output to SCADA. The other nice feature on here is the alarm display. That screen gives you a log of events. Now, the log of events, we can see it gives you a time and a date of when these events occurred. The only time it goes into the log is if you've come out here and acknowledged that you've had an event, whether it be a high alarm, low alarm event. You must acknowledge it, and then it will transfer over into the log. That alarm will stay maintained until it's acknowledged. So an operator must come out here, hit the reset button, and the alarm will go away. So it must be acknowledged. Any questions so far? Yes, sir.
Is that an air dryer, and then?
No, it's not an air dryer. That's an air filter.
Air filter. Okay.
All right. It's a coalescing filter, and it'll take any of the entrained oil. It's a 99.9% efficient filter. We use those mainly on potable water systems, where we don't want any contamination from oil condensate or anything that may be generated by the compressor. So we clean that airstream up. In this particular case, you've got basically almost the same as you would in a potable water system.
And then the two that are underneath the panel there, can you?
These are check valves. Those are check valves. In case that we had a leak between here and there, you're not emptying out any of the air volume within the surge tank. That is there for a protective measure in case someone left a valve open or something, you know, there was a pipe failure, there was a leak, something along that nature. But that way we maintain the air within the surge tank. What you have here is an auxiliary fill. In case that you ever had the compressor failed, you needed to add air, you can bring in a portable air compressor at that stage, and then you could actually put it online. It's mainly there for if you did maintenance and you drained the tank out, you'll need to fill the tank back up to steady state and then charge the tank. It's much better to charge the tank with a larger portable compressor. These compressors are sized for air makeup. They're not sized for actually charging the initial charge of the surge tank. Now, you can, but as we found out, it's going to take about 5 to 6 hours to charge a tank that size with that compressor. So if you don't want to wait around 5 or 6 hours, I suggest you get a big portable compressor in here, charge it up to 120 and let it finish off. It's a good suggestion, and especially if you take the system completely down. Now, it can charge it. I did it, you know, while we were here, but it certainly was a long time. Any other questions? We'll move on from here onto the compressed air system. The compressor that we have here is a very basic single pump, single motor compressed air system made by Gardner Denver. Gardner Denver is one of my favorite compressors out there now. I sell a lot of them. One of the reasons I like Ingersoll Rand too, we're actually a sub-dealer for Ingersoll Rand, but Gardner Denver has kept a wide variety of pumps available where Ingersoll Rand has shrunk down the availability of a lot of their pumps. I mean, you only have 5 or 6 or 7 choices where Gardner Denver has kept their full line. They're made in the USA. They basically have a function of a pressure switch. This pressure switch here is set as a on and off pressure switch. We currently have it set, I believe that it's set at about 150 psi off, and it comes on about 140, somewhere along that range. I think right now we're at 150, that's 160. So you always have to set your pressure settings higher than the maximum pressure that you would ever see in any standard operating condition of the surge tank. Because if the pressure setting wasn't high enough and we had a call for air, then the compressor wouldn't ever turn on. What happens, even though the tank pressure right now, I don't know where it's at, about 120, and we're at 160, what happens when we have a call for air, immediately within, I'd say, 10 or 15 seconds, this air compressor will equal the pressure inside the tank. So that higher pressure gets drained into the tank, and then what happens is this just becomes a pump. And it's just pumping air volume in there and pushing that liquid level down, as we explained earlier. The O&M manuals is inside of your, for this compressor is inside your O&M manuals. You need to check the frequency of your oil changes, and there's not a lot of maintenance to these things other than oil changes and making sure you've got a clean filter. You know, a good visual on the filter. You don't really have a huge dusty condition out here. Your filter should last, I would say you need to replace it at least once a year. But other than that, a quick check of the filter would be great. Your oil change intervals are inside your O&M manual. You need to double check those and change those as required, as stated inside the, because I believe that you've got a fairly good warranty on these, but you need to make sure that you do the oil changes and you use Gardner Denver oil. All right, I mean, there's other compressor oils out there, but if you want to maintain your warranty on these, it's very important that you use their specified oil. The other feature we've got here is this is your auto drain. I love these little auto drains. They don't get clogged up. They're energized to shut when the compressor comes on, so it's under a loadless start, but also it drains any of the condensate that's in the tank after every cycle of the pump. If you had one of those little electronic timers on there, every 45 minutes, that's a maximum they set, you're going to be spewing air every 45 minutes. Maybe fine on a compressed air system that's running all day long, but these aren't. I mean, these are intermittent duty compressed air systems, so you really don't have a big long run time. I think since I've been out here last, this compressor has run a total of 17 hours. And how long, when was the last time I was here? I don't know, about a month ago? About a month ago. So, you know, that's all that you should expect, because it really, I've noticed that it takes about 45 minutes once we get to the add air. This compressor is going to run between about 30 and 45, up to an hour max, before it'll satisfy the liquid level. You have a variety of alarms. Same way on the compressed air system. You've got a high pressure alarm and you've got a low pressure alarm. Those are both set beyond the operating levels and below the operating levels on the low level pressure switch, the low pressure switch alarm. You also have a variety of alarms that's being monitored by SCADA, that's being monitored by the panel, then sent to SCADA. We have the compressor run. That's a function that's sent back to the SCADA system, so they'll be able to see whether it's running or not. Also low oil level, motor overload, and low and high pressure. So those are all the alarms that are used to monitor the compressed air system, and those are all latched alarms. So in every case, if you have an alarm, you're going to have to come out here and acknowledge it and reset it, but it's only going to reset if it's back into a normal condition. So if you're on the low oil level, likelihood is you better add some oil, otherwise she's not going to start. Other than that, that's pretty basic. It's a standard system. There's no other real special features other than our alarms that we have and changing the oil. Those are your main operation and maintenance that you really need to take care of. Any questions? All right.
I have a question about how you have your condensate drain, auto condensate drain.
Yeah.
On the upstream side of your drain valve, so you have to periodically manually open that valve to drain your condensate?
No, it's both. No, that's actually the condensate comes from here. Oh yeah, it's that's why you put. It's got a manual. See, that's a manual drain.
Right.
So you can manually drain it, but it'll draw, if there's any condensate buildup there, it'll draw it through the tube and it'll actually spew it out here. So that's a nice thing about it. There's no maintenance to those at all, and they only actuate after a cycle. And it also acts as your unloading valve.
We cracked it yesterday after it ran for a little bit. We didn't really get any condensate out of it.
No, I mean right now we're in a, you know, I guess monsoon season, you know, we get a little bit of humidity and stuff like that, you're going to get some. Anytime that you're compressing air and you're heating air up and then you're cooling it down, you're going to get some condensate out of whatever humidity that we have in the air. But luckily in California we don't have a lot. And if the drain valve's doing its job, then there shouldn't be, on a manual actuation, you really shouldn't see much there at all. Any other questions? Well, gentlemen, I think that's all I can say is that there's a lot of info in your O&M manuals. I just hope that obviously you guys, our phone number is on the nameplate of this surge tank, because we are the only surge system manufacturer that builds their own vessels. We do everything in-house, and if you've got any questions, I maintain a library of these O&M manuals, so I can, for the most part, if you ever have any trouble, I can typically 90% of the time take care of it and walk you through it over the phone. So, you know, we're always there as a support mechanism for you. If you've done everything that you think that you know and you still hadn't figured it out, you can certainly give us a call. And so we're certainly there to help. But that's going to conclude our training today. Appreciate it. I know it's somewhat boring sometimes, but hopefully you guys can retain some of this, but if not, there's always good reading material. All right, thanks.
Thank you.